Okay, so I got a video request for exercise 6.50 with feedback. This is Hess's law, as you can see. And let me remind you something about Hess's law before we begin. Let's go here and say that the idea of Hess's law is if you have some reaction, A, let's say, plus B produces C plus D, and we know that this has got an enthalpy of the reaction, a molar enthalpy of reaction of, let's say, 10. I'm going to say joules. Just making something up. Another reaction that is C plus D produces E plus F. And this has a molar enthalpy of reaction of, let's say, 5 joules. Okay, and then you're asked. This is the idea of Hess's law. Hess's law. I hope I'm spelling that right. Hess's law is if you take these two reactions here and then you add them, you can also add these. All right, that's really what the law is. So let's say we have another reaction. We're asked, well, if we have A plus B produces E plus F, right? Can you see that this is reaction 1, reaction 2, and reaction 3? Can you see that the sum of 1 and 2 is really 3? Right? Because what's produced in reaction 1 is consumed in reaction 2. So if I add all these up, then we're going to get, we add all the ones from 1 and 2, we're going to get 3. So what's the enthalpy of reaction for reaction 3? Well, it's going to be the sum of these two. Okay, sorry about this. We'll look at that later. Okay, so that's really what the essence of Hess's law. So I'm going to get rid of this. Come back over here. Add another one for when we need it. We'll come here. All right, so that's Hess's law, that's what we're doing. So whenever we see that, if we want to know the molar enthalpy of a reaction for this reaction, we sort of look down at these ones and say, how can I sum these up to get this? I'm going to call this reaction 1, this reaction 2, and this reaction 3, and I'll say that this is reaction 4, just making stuff up. So it looks like in reaction 4, I am going to produce some HCl's. So in order to produce 4 HCl's here, let me get a different color here. In order to produce 4 HCl's, I'm going to have to use reaction 3. And it looks like I'm going to have to use reaction 3 times 2, right? So I'm going to watch this. I'm going to go 2 times reaction 3. I'll circle these so we know what those are, okay? 2 times reaction 3 is going to be H2 with a 2 in front of it plus 2Cl2 produces 4HCl. Gas, right? And that's exactly what I wanted there. Okay? So we took care of that one. Now let's go back over to this and say carbon tetrachloride. It looks like there's only one place carbon tetrachloride comes in. It's right here. Okay? And there's only one. One here and one here. So it looks like I can do 1 times reaction 2. And it's in a product also. And this is also a product, right? 1 times reaction 2 is going to be C plus 2Cl2 gives me carbon tetrachloride. Okay? Oh, by the way, I should put the enthalpy of reaction over here, enthalpy of reaction over here. This is 2 times this enthalpy, so this is going to be 2 times minus 184.6. I'm going to leave the units off for now. And this is 1 times this one, so it's minus 95.7, right? Can you see that that's reaction 2? All right, now I got a problem. The problem is that I've taken care of these guys, but I've got all these extra junk in there. And so we need to have, watch this, 4 Cl2s which I have, right? This is correct. This is what I'm looking for, and this is what I'm looking for, but I got to get rid of my carbon here because there's no carbon up here, right? And there's no methane. I haven't run any methane either. So it looks like if I take, I'm looking for this one now, and I see it here. Looks like I'm going to have to turn this guy around, though, because this is a reactant. And this is a product. So I'm going to turn this guy around, reaction 1. I'm going to take reaction 1 and multiply it by -1 maybe. Let's see, how many methanes do I have here? Yeah, if I just turn this around once, -1 times the reaction 1, that'll give me, where am I, red? CH4 produces 2 H2s, right? I'm doing reaction 1 now, plus a carbon. Okay, now I turn this guy around, and so I'm going to have to make this, I'm going to take the negative of this, and this makes it actually now positive 74.6 kilojoules. Okay, so let's look at this now. Let's go with our yellows again. I've got my methane there, and my methane's taken care of here. And my carbons are crossed off, right? Boom and boom. And my hydrogens are crossed off, boom and boom. So let's take the sum of all these guys here. I'm going to do it in yellow now. Hope this is not too many colors. The sum is CH4, I just took care of that now, plus 4 chlorine gas, take care of that now, produces, because everything's crossed off here, you see that? 4 HCl, took care of that, plus carbon tetrachloride, took care of that. Everything's crossed off now, we're golden. So it looks like all I got to do is now add up all these guys, and I'm done. And there it is. Well, oh, we have to verify this is the same reaction. Sure enough, this, let me do one more color here, just so you guys can see what I'm looking at. That is here. This is here. Here's a reactant, and that's a reactant, and here's a reactant, and here's a reactant. So we're golden. That's exactly what it is. Now all I have to do is add all these numbers up, and I'm done. So I can't do this in my head. So what I'm going to do, I'm making a video here. I can't do this in my head. So what I'm going to do is I'm going to pull out a calculator here and say, I got to go into Python. I'm about to get kicked out of this classroom, so I'm going to rush 2 times minus 184.6 plus minus 95.7 plus 74.6, and so the answer is going to be minus 390.3. Minus 390.3. Let me go back over here. Minus 390.3, and that's it. Kilojoules is the heat of this reaction. Equals minus, or rather, the enthalpy of the reaction here, the molar enthalpy of the reaction is minus 390.3. Okay, hope that's helpful. Talk to you soon.